Use your calculator to graph y equals e to the x and its derivative on the same coordinate plane. To do that, you're going to put y1 is equal to e to the x, and then y2 is equal to the derivative of y1 with respect to x. What do you know? They're the same graph. E is the only base for which the basic exponential function and its derivative are the same. When you have u, a function of x, the derivative of e to the u is e to the u times u prime, and here it is with an exponential. Right here you have an e to the u. U is equal to x squared minus 3x. U prime is equal to 2x minus 3. To get y prime, we take e to the u prime. There's your answer. Number 2 is another e to the u. U this time is negative 3 times t to the negative 1. So u prime would equal 3t to the negative 2. E to the u times u prime. This is 3 to the power of u. U is v to the 1/2, making u prime 1/2 v to the negative 1/2. F prime of v, a to the u prime ln a. There's our answer. For number 4, find the relative extrema, list as points, and do not use a calculator. For relative extrema, let's make an f prime number line. Continue simplifying. And why did I always ask for fully factored form? Because it needs to be fully factored in order for you to find the zeros, or in this case, the critical numbers. Critical numbers are where the derivative is equal to 0 or where the derivative is undefined. Now it's time to make an f prime number line. So we know that our critical numbers negative 1/2 and positive 1/2 give us relative extrema. At negative 1/2 we have a relative max, and at positive 1/2 we have a relative min. They did ask for the points, so we need to find the y values as well without using a calculator. Our relative max is at negative 1/2 positive 1 over 2 root e. Our relative min is positive 1/2 negative 1 over 2 root e. For integrating exponential functions, remember you must have u prime in the integrand before it can just integrate to be e to the u. Similarly with a to the u, you must have u prime in there, just like when we were integrating with reverse chain rule. That's what we're doing here. In this case, a to the u is x squared minus 1. U prime is 2x. We have an x in our integrand, but we need that too. So I'm going to multiply by 2 times 1/2. The integral of a to the u prime is a to the u over ln a, evaluated from 0 to 1/2. Plug in your limits and simplify. So I factored out the 4 with the smallest exponent. We could even write this as 2 ln 4 and factor out the ln 4 as well. Four to the negative 1 will now be in the denominator, times that 2. 4 to the 1/4 minus 1. You could leave it as a fractional exponent. For number 6, e to the u would be 2 over x. So u prime would be negative 2 x to the negative 2. So this integral needs to have negative 2 over x squared inside of it. I'm going to take the 1/3 out of our integrand. And I need a negative 2 in there. So I'll do negative 2 times negative 1/2. The integral of this is just e to the u. Once you've established that u prime is in the integrand, you can use the formula. I'm going to write this as a product of powers. In this case, I have a quantity to the power of negative 4 and then some other quantity here. So I might be able to use reverse chain rule. Let's hope it all works out. U would equal this quantity inside, that is to the power, e to the x plus e to the negative x. That means that u prime is equal to the derivative of e to the x is e to the x plus e to the negative x times the derivative of negative x. That makes u prime e to the x minus e to the negative x. OMG, that's right here. So if you're noticing, this is basically u to the negative 4 times u prime. So you can use the general power rule for integration. You would add 1 to our exponent. That would become your denominator plus c. But let's do it in terms of x. U to the power of negative 3 over negative 3 plus c. And that's our result.